Okay, let's continue. This is part B of my sort of chapter 1 review videos. This is coming from the book. This covers sections 1.2, which is monomials and radicals. So we have a lot to do here. Let's get started. Use the properties to simplify each of the following expressions, blah, blah, blah. Okay, remember I told you we're going to use the PEMDAS model, and basically you step down from each operation. So if it's an exponent, you actually multiply. If it's asking you to multiply, you add. If it's asking you to divide, you subtract. Now, these are rules for exponents. Where are exponents? Exponents are the numbers at the top right corner. They are not coefficients. They are not on the ground. They are not bases. Those rules that I just wrote down using the PEMDAS model only apply to the numbers in the top right corner. Okay, number 16. It's negative 14, t to the 0, s2, t, negative 2, all that to the negative third, 2 cubed, st to the negative third. Okay, off the top, we had a rule that said anything raised to the 0 power is 1. So I'm just going to scratch that out, and that's going to be a 1. I'm also going to distribute this. Now, this is an exponent. See, right here, exponents mean you multiply. This is an exponent. And so we're going to multiply negative 3 here. So negative 4 times 1 is negative 4. 2 times negative 3 gives me s to the negative 6. And negative 2 times negative 3 gives me t to the positive 6. Let's work in the denominator. 2 cubed. 2 cubed is 2 times 2 times 2. This is a coefficient. 2 is a base. It is not 2 times 3. It's 2 times 2 times 2, which your entire life is going to be 8. And then we have st to the negative third. Okay, let's do some reduction here. Negative 4 over 8, this is going to reduce to negative 1/2. I need to move s to the negative 6 down. And when I move it down, it will become s to the positive 6. I need to bring t to the negative 3 up, and when I do that, it will become t to the positive 3. So again, this s I moved down, so I'm going to scratch it out. This t I moved up, so I'm going to scratch it out. So all together on the top, I have a t to the 6th, and I have a t to the 3rd. On the bottom, I have a plain s, and then I have an s to the 6th. We just combine. We are asked to multiply these t's, and we're asked to multiply these s's. And if you go up to the top, if you're asked to multiply exponents, that actually means you're going to add them. So this is going to be negative t to the 9th. You don't have to put your 1. It's understood. Over 2s to the 7th power. Now that problem may be familiar to some of you because I feel like that was on a quiz that I gave. Let's look at number 17. Brackets, parentheses, 3y to the negative 2z, all that's being raised to the negative 1, and then all of that is being raised to the negative third. Now, these brackets and these parentheses are really, really important. This is telling me that this entire monomial, it's one term, it's a monomial, this entire monomial is being raised to the negative third power. And the parentheses tell me that the monomial is also being raised to the negative 1. Well, the easiest way to do this, and there are other ways, but I like to go for the easiest way, is to just combine these. We learn from the top, if you have an exponent, which I think we will all agree that this is an exponent, and we would also agree that this is an exponent. And the rule is if you have an exponent, you're going to multiply them. So this is going to be 3y to the negative 2z. I'm not going to do anything with that yet. But I'm going to multiply the negative 1 times the negative 3, which is going to be positive 3. And see, automatically, boom, this is a pretty easy problem. All I have to do now is cube everything in the parentheses. Now, 3 cubed is the same thing 3 cubed has always been because 3 is a base. It is not an exponent. So 3 times 3 times 3, that's what 3 cubed is. That would be 27. Here we're going to multiply because, again, this is an exponent, and if you go to the top, if you have an exponent, you're actually going to multiply. So negative 2 times 3 is negative 6. Even if you can't see it, there's a 1 on this z, so 1 times 3 is 3. And you cannot ever, 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 ever ever leave a negative exponent in your final answer. So that means this y to the negative 6 needs to move down. And when it comes down, it will become a positive. So we have 27z to the third up top, y to the 6 in the denominator. And nothing can be simplified there, so that's the final answer. Number 24, let's keep going. The square root, oh my goodness, I don't know if I can see this, is 25x to the, I think it's a 30. I cannot read that, to be perfectly honest. I'm sorry, I cannot read it. But anyway, we're going to take the square root of 25, which is 5. And then for your exponents, you divide the power by the root. Remember the little child's toy that I told you? Power Rangers. So since this is the square root, we're going to divide 30 by 2. That's going to go in there 15 times with a remainder of 0. The whole number gets out, the remainder gets stuck. So for this particular problem, 15 x's get out and nothing gets stuck. Now, to be perfectly honest, that may not be a 30. I'm sorry, I cannot see it. I apologize. Let's move on to number 25. It's 3 over the square root of x plus the square root of 2. Take this one to the bank. This is two things. One, it's something that students don't like. Two, it's something that is extremely important throughout Math 171 and particularly later in 172. This is a binomial. How do I know it's a binomial? Because it had an addition or subtraction sign in the middle. Read your flow chart. I've got the instructions for what to do if you're rationalizing the denominator of a binomial. But really quickly, you're going to multiply the top and the bottom by what's called the conjugate. The conjugate is the exact same term. So in other words, if this has a radical x, my conjugate has to have a radical x top and bottom. If this has a radical 2, my conjugate has to have a radical 2 top and bottom. But you change the sign in the middle, only the sign in the middle. So if this was a plus, the conjugate would have a subtract. And this is what you call the conjugate. You have to have that right on anything I grade. If you do not have the conjugate written correctly, I don't give you any credit. It's that important. Okay, now we're just going to distribute the top. The 3 is out of the radical and the x is in, so I cannot combine those. It's just going to be 3 radical x. 3 times radical 2, again, one is inside, the other one is outside, so it's just going to stay that way. Now, the special thing about conjugates is that you only have to multiply the first and the last. If you FOIL them, the outer and the inner will always cancel if they are conjugates, okay? So don't apply it to every single problem, in the universe, only conjugates. But the first times the first, radical x times radical x is going to give me radical x squared. And then the last, a positive radical 2 times a negative radical 2 is a negative radical 4. Now, for conjugates, when you multiply them, you're always going to have a subtraction there in the middle because one term's always going to be a positive, one term's always going to be a negative, and a positive times a negative is always going to give you a negative. So on the top, there's absolutely nothing I can do on the top. So 3 radical x minus 3 radical 2. Those are not like terms. In the denominator, I told you this, but remember a square and a square root are opposites. So this like gets caught up in a tornado and goes away. We're just left with x, and the square root of 4 is a plain 2. So that is the final answer. Again, this is something that students hate, and I don't understand because it's not crazy difficult. This particular problem is not. Now, we will get to some on a later section that are really hard. But that one is pretty basic, and it's something that you need to know. It comes up a lot in Math 172. Moving right along, let's see if I can read this one. Okay, I think this says the cube root of 8x squared over 3y to the negative 4. I hope that's what that says. We have some simplifying we can do here. I'm going to move that y to the negative 4 up. So here's my new problem. Cube root of 8x squared y to the positive 4 all over 3. Let's keep going in this direction. I can take the cube root of 8. The cube root of 8 is 2, so let's go ahead and do that. We divide our x squared. That's not going to get out, so I might as well go ahead and put that under the cube root because x squared is not going anywhere. You've only got 2 of them, and you need 3. But for this one, I can divide the power by the root. That is 1 remainder 1. So 1y is going to get out. 1y is going to get stuck. So I'm going to have 2y out, and then I'm going to have a y stuck. Again, I'm having a really hard time reading this, but I think that's correct. And then in the denominator, I'm just going to rewrite it as the cube root of 3. I'm going to give it its own little symbol there. I know the problem wrote it as one big cube root, but you can separate it. The top is taking the cube root, the bottom is taking the cube root, and I just think it would be easier if I separated those two. So let's keep going here. Now, what we have to do is we have to rationalize this denominator, and this is a monomial. It is not a binomial, so conjugate doesn't even come into play here. This one is really complicated. I don't think that we've done a cube root, and if we have, maybe only one. I'll be perfectly honest, I'm not going to put a cube root like this on the test, but it's really good practice, so let's keep going. If you're looking for the cube root, you need 3. Let me cut my phone off. You need 3. Well, right now, I only have 1. So what I need is 2 more 3s. I need to multiply this by the cube root of 3 there, and then I need another cube root of 3, because if I'm taking the cubed root, I need 3 of whatever the term is. This is the evil radical, and I need 3 of these things. I need 3 of these cube roots of 3 in order to take the cube root. If it was the 4th root, I would need 4. If it was the 5th root, I would need 5th. If it was the square root, I would need 2. And since I multiplied the bottom by cube root of 3 and cube root of 3, I also have to multiply the top by the cube root of 3 and the cube root of 3. See, I already had 1 down there. I just need 2 more. So I'm going to multiply the top and the bottom by 2 more cube roots of 3. So on the top, I have 2y cube root. I'm going to just multiply all this together. X squared y times 3 is 9x squared y. And then in the denominator, the cube root of 3 times the cube root of 3 times the cube root of 3 is the cube root of 27, which should sound good to your ears because we can take the cube root of 27. The cube root of 27 is 9x. I'm sorry, let me copy the top. 9x squared y is your numerator. The cube root of 27 is just a plain 3. So we have now rationalized the denominator of a cube root problem. Again, that's a tiny bit harder than what I'm going to put on the test, but it's just such amazing review. I don't want to stop. My video is about to end because you can only record 15 minutes at a time. So I'm going to stop there. I'll come back with numbers 27 and 28.